In this video, we're going to go over the Module 3 practice problems for calculating confidence intervals. Here we've got our equation for the standard error of the mean, as well as the confidence interval for a population mean based on a sample mean. So I've given you guys the sample mean, which is 60, and based on the units that you see, we are looking at VO2. And then each of the scenarios we have got, we're going to use this given information to calculate the confidence interval based on a certain level of confidence. So to make things easy, I've given you guys different levels of confidence that are oftentimes used in various forms of research. The z-scores that are associated with those levels of confidence. So we could find these by looking at the z-table and then saying I want the z-score at 99% or 95%, and we end up getting these values. So these would be the z-scores that you're referencing in your confidence interval equation. And then if you recall, 100%, or if we converted these percentages to values between 0 and 1, we could say that 1 minus any of these level of confidence values as a decimal gives us our alpha level. So 1 minus 0.99 or 100 minus 99% would give us 1% or 0.01, and so on and so forth for all of the other levels of confidence. So then this becomes our alpha, which helps us to determine if our sample mean is significantly different from our population mean. And we say population mean in quotes because we don't actually know what our population mean is for these types of examples. What I've done is I've linked a practice problem Excel workbook. It is a view-only format. That way you don't mess up the workbook for your classmates, so you will have to download it from the online version of Excel. And when you do that, you will get a spreadsheet that looks like this. And we can see up here, this is the example for a sample mean of 60. I've input all of the sample sizes, the standard deviations, the level of confidence, as well as the z-scores that are associated with those LOCs. So really what we need to calculate in order to figure out what our confidence interval is the standard error of the mean. And in order to calculate the standard error of the mean, we need to know standard deviation and the sample size. So we can easily do a plug and chug method here by just typing in the equation equals. We can do a cell reference for our standard deviation divided by the square root of our sample size. We can then press enter and copy this down, and then we have the standard error of the mean for each of our different examples. From here we can then calculate the lower and the upper bounds of our confidence interval. The lower bound, simply we're following this formula down here, so it's our sample mean, which we said was 60, so this is a constant. And then we do minus, because we're going below the mean, z times the standard error. Now Excel should pick up on the order of operation, doing the multiplication first and then the subtraction part. But if you're like me and you just like to be extra careful, you could put parentheses around the multiplication to ensure that that goes first. So we press enter, and again, copy downwards. For the upper bound of the confidence interval, instead of doing minus, we are going to do plus. So we'll do the same thing, equals the mean plus our z-score, and I'll do, z-score, there we go, times our standard error. And now we have our upper bounds of our confidence intervals. And if we want to know the interval size, all we have to do is look at the difference between the upper and the lower bounds. So it's kind of like calculating a range, where you have a minimum and a maximum, and you look at the difference between those two. Interval size is pretty much the same ordeal. So then we can look at our data, right, and then look at how the bounds of our confidence intervals change based on different factors that are also changing. So in our example, our sample mean stays the same, but our sample size does change. And what we can notice, if we look at these middle two examples, where our level of confidence is relatively the same, right, we can see that as our sample size increases, our interval size decreases, right? So instead of when we have a smaller sample size, our interval is wider than if we had a larger sample size. So in this case, if our confidence interval becomes more narrow, we are able to be more precise about where our actual population mean would be located. As we look at differences in the level of confidence, right, as our intervals get larger, right, going from a smaller interval to larger intervals, you can see that generally our interval size widens. And that's because the confidence interval is including more and more data in our sample. The other thing we can note is looking at how standard deviation might have an effect. So as we have larger standard deviations, that directly goes into the numerator of the standard error. So standard error and standard deviation are proportional to each other, or they're directly related, meaning that as we have greater variation, we should also expect to have a greater standard error. And the larger the standard error is, the larger our confidence interval should be. We don't really get the best example of that in here, just because we've got a lot of different factors that are being changed at the same time. So those effects might not really show up in this data, but we can use our equations and how they affect each other, or how certain variables and changes in those variables affect the outcomes of different equations, to kind of see how we might expect these different factors to affect the confidence interval size. Now let's look at an example. Say that our sample mean, instead of being 60, we decrease it to 50. So we'll do the same process, equals standard deviation divided by the square root of our sample size. So we should essentially have the same values here. What's going to change is the mean. So now we're going to do, for our lower confidence interval, we do the mean, 50, right? It's over here, minus our z-score times the standard error. And to get the upper confidence interval bound, we would do our mean, 50, plus our z-score, parentheses, times our standard error. And then we can do the same thing to calculate the interval size by just subtracting the lower bound from the upper bound. And what we can notice is that when the mean changes, our interval sizes stay the same. But what happens is that our confidence intervals shift left or right. In this case, because we have a smaller mean than compared to our first set of examples, you can see that the confidence intervals shifted the exact same units that the mean value shifted. So the difference between 60 and 50 is 10. And we can see that the difference between our various examples that correspond to each other are a whole 10 units. So we can point out some interesting effects based on different factors that are going to influence where our confidence interval lies, as well as the size that our interval will show up as. So we can see when the mean increases or decreases, that's just going to cause a shift in the confidence interval from left to right. And that's simply because, if you recall, our distribution shape is built off of our units of measurement, right? So where our mean is in the center, as we move outwards plus or minus 1 or 2 or 3 standard deviations, each of those standard deviations could also be expressed in the units of measurement. So in this case, if we were looking at this example, like the first one, where our standard deviation was 4, our sample mean is 60, so that would be in the center of our distribution. If we moved 1 standard deviation away from the mean in the positive direction, we would then have 64, then 68, then 52, etc. Same thing if we go in the other direction. So literally just changing the mean is going to change our interval left to right, but will not impact the size of the interval. When we increase our sample size, that's going to narrow our confidence interval and make it more precise. Okay, so the boundaries are going to get closer and closer together, and we have a better pinpoint of where our population mean would actually exist based on our sample data. When we change the level of confidence, so if we're choosing 90 versus 95 versus 99, that's also going to change the interval size, right? And this one I think is a little bit more intuitive in how it impacts the interval size, because the percentage is what we are including in our boundaries, right? So the larger our percentage is, the wider our interval size will be. The smaller the percentage is, the smaller the interval size will be. And that is it for our confidence interval practice problems. If you have any questions, please shoot me an email and I'm happy to help you out with anything that you might be having trouble with.